Okay, we're going to integrate this function that involves exponentials and sines and cosines. And I'm going to do it with two different approaches, really accomplishing the same thing, just one's faster. And you could say this requires a u-substitution, and that you would let u equal 2 cosine x and then try to find du in the integrand. All that's really about is recognizing the consequences of the chain rule backwards. And what I'm looking for is a function of a thing, so e to the 2 cosine x, next to the derivative of that thing, so the derivative of 2 cosine x. And I've almost got it here, because the derivative of 2 cosine x would be negative 2 sine x. So my strategy is going to go like this. The derivative of that exponent is negative 2 sine x. So I'm just going to put a factor of negative 2 in there to get it done, and then I have to make up for it by multiplying by negative 1/2 out in front. So I have e to a thing sitting right next to the derivative of that thing, and I can recognize the chain rule backwards. And we're done. It's really fast. This is how people actually do u-substitutions in real life most of the time, except for some rare cases where they're actually mandatory. I wanted to check real quick because it might feel a little reckless to do it that way. And with practice, you'll be doing the check in your head, I hope. So if I look at the derivative of negative 1/2 e to the 2 cosine x, I don't care about the c. That's negative 1/2 derivative of e to the 2 cosine x. Well, I just get e to the 2 cosine x. That's the derivative of e to the 2 cosine x with respect to its exponent. And then the chain rule says you've got to tack on the derivative of the exponent. That's negative 2 sine x. All right, my negatives are going to cancel, my 2's are going to cancel, and I get what I started with. So I know it works. And this, to me, it really captures the essence of what u-substitution is almost always about, and that is just recognizing the results of the chain rule in reverse. If you wanted to be more formal about this, you could have said let u equal 2 cosine x, then du is just negative 2 sine x, the derivative, times dx. And at this point, you could take the same strategy of saying, okay, I want to build a negative 2 sine x in the integrand. So my integral is e to the 2 cosine x, negative 2 sine x, dx, multiplied by negative 1/2. And this chunk over here is du, and this chunk over here is e to the u. And I get negative 1/2 integral of e to the u du, which is just negative 1/2 e to the u plus some arbitrary constant c. Replace u with its definition in terms of x. If you don't do that, the problem isn't done. Negative 1/2 e to the 2 cosine x plus c.